Alright, we're looking at 6. Compound containing carbons, hydrogen, and oxygen has a molecular weight or molar mass of 262.3. If we combust 0.1 exactly grams of this compound, it'll cause a 0.2014 increase in the mass of a CO2 absorber and 0.07553 for H2O absorber. Alright, those two absorbers are going to end up telling us how much carbon and how much hydrogen is present. Alright, how that's going to work, I'm going to look at the molecular weight of carbon dioxide compared to just the molecular weight of the carbon in there as a conversion factor. And then I'm going to do something similar with the water with the molecular weight of water, and on top here I am going to put 1.008, the molecular weight of hydrogen, but since there's two hydrogens in there, I'm going to say multiply it by 2. Alright, going to use those two conversions to figure out how much carbon's in there and then how much hydrogen's in the sample. Alright, so that 0.2 grams of carbon dioxide tells us that there was 0.05496 grams of carbon specifically, and 0.07553 times 1.008 times 2 divided by 18.016 tells us that we have 0.008452 grams of hydrogen. Alright, we're going to get the grams of oxygen by difference. So we know there's exactly 0.100 carbon, hydrogen, and oxygen. So I'm just going to subtract the hydrogen and subtract the carbon. And I get that that should be around 0.03659 grams. Alright, just like a standard empirical formula calculation, we'll convert each of these masses into moles using the molecular weight of each of those individual atoms. So take that 0.03, divide it by 16, and I get that that is 0.002287 moles of oxygen. The 854 is the mass of hydrogen. Divide that by 1.008, and we end up with 0.008385 moles of hydrogen. And now, does this go up high enough to get the carbon? Yeah. So the carbon there divided by 12.01, we get that the carbon is 0.004576 moles. Alright, the oxygen's the lowest, so I'm going to divide everything by that 0.00287. 2287. So this divided by the 2287 gives me a roughly 2, and the 0.008 divided by the 0.002 gives us 3.66. And that'll be 1. To get rid of that third, I'm going to multiply all these by 3. So that is C6H. Just so you see that, 11O3. Now that's an empirical formula. To figure out if it's the actual molecular formula, we're going to figure out what that weighs. So if we had 6 carbons at 12.011 grams and 11 hydrogens and 3 oxygens, we get something like 131. And that goes into 262, well, not when I do the math like that. It goes in there twice. What the heck? Try that again. There we go. Giving us a molecular formula of C12H22O6.